So now this is at 45 degree. So for 45 degree I have put 20 grams, and if I tap, you can see that it's moving down. So for 20 grams W1, 45 degrees, so W1 would be 20 plus 13 because it's moving down. Similarly we will calculate W2. Now for 45 degree again we are calculating W2. So again if I tap, you can see that it's moving up. Let you see again. So you can see that it's moving up. So this is W2. Now I have put 50, 60, 70, 85. Let me count again. 50, 60, 70, 80, 85. So my W2 would be 85 plus 13. So my mg calculation, mg would be W1 plus W2. So W1 would be my 33 plus W2 is 85 plus 13. How much is that? 95 plus 7, 102, 103 divided by 2 into sine of 45 degree, which is 1 by root 2. So I can write this as root 2 into root 2. So root 2 cancels off. So basically it's 136 divided by 139 divided by root 2. That is my answer. So you can calculate that how much it will get. So then similarly you will do for 37 degree. So I got 98 grams for the second reading. So I'll write here 98. Now for the third reading I have to set the angle at 37 degree. So now we are at 37 degree. So for this we are finding W1. So I have put 10 grams over there. So if I tap, it's coming down. So my W1 value would be 10. So for 37 degree, W1 would be 10 plus weight of the pan, which is 13. Now for 37 degree again, I am calculating W2. So I have put here 70 grams, 50 plus 20 plus 10. Sorry, 50 plus 20 plus 5. So that's 75 grams. So if I tap, you can see it is going down. So going up. So my W2 will be 75 plus 13. So if I calculate my third reading, it would be W1 plus W2 by 2 sin theta. So W1 is the 23, W2 is 88 divided by 2 into sin theta is 0.6 because sin 37 is 0.6. So if I calculate that, so I'll get 88 plus 33 divided by 2. So I got 60.5 divided by 0.6. So I'm getting around 100.8 or something like that. So if I calculate an average like this, 100.8, so I'll get my average estimated weight of the roller came out to be 96.6 gram. So the actual is actually 92 grams. So I'm off by 4.6 gram, which is okay. So that concludes our experiment. So let's start with this experiment. The aim of the experiment is to find to estimate the weight of the roller using inclined plane. So the principle is, one of the principle involved is resolution of vectors, while the other principle is Newton's second law, which states that if the net force acting on the body is 0, then the acceleration is also 0. So this is the diagram of our experiment. This is the roller, this is the pulley, and this is the weight. So if I assume weight to be W1 plus W2 by 2, then this is mg. Mg is the weight of the roller. If this is theta, then this is mg cos theta and this is mg sin theta. Basically I have resolved the vector mg into mg cos theta and mg sin theta. Now if I want the roller to be not moving at all, that means at equilibrium, mg sin theta should be equal to tension in the wire. Otherwise the roller will move down. So at equilibrium I can say tension in the wire should be equal to mg sin theta, because mg sin theta is the force that is responsible for the motion of the roller. So if I can balance mg sin theta with the tension, then the roller won't move. That is the condition for equilibrium. So T is equal to mg sin theta. But we also know that T is also equal to W1 plus W2 by 2 here. So we can directly equate them and solve for mg. So this is our formula. So basically you have to write the principle of the experiment, diagram, and then the formula, and you have to explain what is W1 and what is W2. So basically W1 is the weight on the pan, W1 is the weight on the pan, corresponding to which the roller will just start moving down. When you tap it in front here, somewhere if you tap it here, the roller should start moving down. Then the weight corresponding, the weight which is on the pan is W1. W2 is the weight on the pan when the roller will just start moving up. When you tap, the roller should move up. That's W2. Now let's do one observation. So this is your observation pattern. So weight of the pan will be given. Here it is 13 gram. And these are the three angles at which the experiment is to be done. So angle is 30 degree, which is sin theta is, sin 30 is half. So this is the apparatus, this is the pan, and this is the roller. And now I have to put weight on the pan, and when I tap it here, if it goes up, that's W2. If I tap, if it goes down, the weight on the pan is W1. So now I have already put 10 grams here. I am putting 50 more grams. So total there are 60 grams, and in addition the weight of the pan is also there. Now as you can see, if I tap, it's going up. You can see that. Yes, if I tap, it's going up. So that means whatever the weight that I have there, that's W2. So I can write W2 as 60 grams because that was the weight on the pan. This is 50 and this is 10. So that's 60. 60 plus weight of the pan, which is 13. So that's W2. Now W1 means when I tap, it should go down. So for that, I'll have to remove 50. Then let me put some 10 grams or 5 grams or something. Let's see. So I'll just put 5 grams and I'll take out 10 grams. Okay. So it's already going down. See, I have put 5 grams there, and when I tap, it's going down. Right? So you can see it once again. So it's not moving now. So when I tap, it's moving down. So whatever the weight I have put should be W1. So that's 5 grams. So my W1 would be 5 plus the weight of the pan, which is 13. So my mg would be, my calculation would be mg is equal to W1 plus W2 divided by sin theta. So here my W1 is 13 plus 5, which is 17. Sorry, 18 plus W2 would be 73 divided by sine of into 2. Sorry, the formula is W1 plus W2 divided by 2 into sin theta. That is my formula. So sine of 30 degree into 2. So this would be nothing but 91 divided by half, because sine 30 is half, into 2. So half and 2 cancels out, so 91 gram. So my result would be, the estimated weight of the roller is 91 plus. I have to do 2 more observations, so I have to do plus here divided by 3. Then I'll get my answer.